we started the recording. So we are discussing this question starting for today's class. The left side should be clamped, it is obvious, and then we have to place some load over here which should make the bend object uh, wooden board bend somewhere, and we are supposed to have a relationship between S and L. So S is the vertical drop, which is defined as the deflection. L is the relevant length for how much it is hanging out of this thing. It is such that the relationship between S and L is given by E equals to 4 mg L cube by BST cube, where G is the acceleration of the free fall and E is the Young's modulus of the wood. This is an elaborate experiment to test the relationship between E, S, and L. Explain how your results could be used to determine the value of E. Okay. In this question, apparently the M is supposed to be a constant because they are saying already that we are trying to find out the relationship between S and L. So these are the two which are supposed to be our variables. So we have to work with a fixed amount of mass. However, every single reading should be repeated to avoid to get more reliable results. So that can happen. And to achieve this relationship, we need to have a couple of things. First of all, there should be a clamp on the left side, which is obvious. There should be a fixed amount of mass by which we are working, which should be uh, good enough, large enough, so that this gives us significant bending for the wooden plank. And for the experiment to work, what I believe is that this load should not make permanent deformation to this wooden plank. So this wooden plank uh, should not be so much thick that it does not give any deflection at all. For example, this can be made out of some sort of plywood, long section of plywood, which should have enough elasticity. And then again, this should not be so much thin that it breaks under the effect of certain load. And obviously and necessarily, this wooden plank should not undergo plastic deformation while taking some reading. What I mean is that, let's say for a certain length, we get it to be bending, and then we remove the load, and then the wooden plank remains in this shape. If that happens, then this experiment should not work, because we're supposed to have a relationship between S and L, which means these values has to be repeatable and they have to be changed between each other. Which brings us to the idea we have to work with a fixed M. So M is a control variable. G is a gravity-based location. And in this case, I think B and A, what is B? Do they say anything about the B? Acha, yeah, B is the thickness of the wood. So B is we're going to use a single piece of wood, or we can use identical pieces of wood, which, so if there is any possibility of uh, of uh, plastic deformation, so that we can continue further down the experiment. What I mean is that, let's say you take three set of readings with multiple repetition, and then the wooden plank bulges away. So you have to use a new piece of wood. So we should have access to multiple pieces of wood. One of the other challenges for this question can be, because as you can see over here, we have placed one of the other important part of the experiment is that we have to have a reference line that should be available to us, that that is aligned with the top surface of the wooden plank and extends in a horizontal manner. So achieving this thing can prove to be a bit difficult. We might as well have this with a meter rule that should be placed on its side and clamped along on the bench as well. What I mean is that if you think of a meter rule is a rectangular object which has a flat side and then has a thin side. So we can place the thin side at the base so that the meter rule will be resting on its side, so that we can have a reference for this dotted line, and then we can measure this length pretty accurately. One of the other difficult thing can be that the question says that we have to place the load right over here on the side over here, exactly over here, and then we should be able to do this. So if you try to think about it, placing loads exactly on this point would be pretty difficult for us to achieve. The reason is that if you place loads exactly on this point, these loads will tend to roll over. they're gonna fall over whenever the wooden plank is gonna be bending. Uh, that's what I think. I mean, this is just an immediate response. So, and also, but you have to place it exactly on this point, as located over here. So, and also we have to, and also if we place the load exactly on top of this part, having the loads exactly located on this point P might be a very difficult thing to achieve, because if you would have the question of balancing and actually stability of those loads on the wooden plank. Another thing which is very important is that measuring the value of S, if you place the loads over here on the top side, might also prove to be pretty difficult, because that way you will be obstructing the measurement point. So in my opinion, one achievable way can be that we can have a string or metallic wire that is pinned with a nut screw over somewhere over here, that should roll over this strip and come over this point and make a hanging pot, or like a hanging mass system, and we should be loading those masses onto this part. That way the top surface will be perfectly free of the loads. Your load would be located somewhere on the below, but you would be perfectly applying the loads or exactly on this exact point on the upper edge of the wooden plank. So loading the loads on top of the wooden plank might not be a good idea, because you can change that scenario. And in this entire question, the question doesn't have the included the mass of the wooden plank itself included. It's only working with the m of the applied load that we are going to be working. So I think that's a pretty important thing, because we can consider that the total mass of that wooden wire or the hanging system that can be considered as an inclusive part of the m, or that can be considered negligible for experimental accuracy. Because you have to think that to be able to bend a piece of wood in this manner, we are talking about kgs of load. We're not talking about grams of load, because to have any significant deflection, you would require a pretty large amount of load. Also, which also is highly dependent on how much overhang the L part, unsupported part of the wooden plank do you extend over the table. That's also a very important variable, because the longer L that you're gonna have, the S should also be significantly larger. So that's another thing. And we should have appropriate ways to measure the linear dimensions. For example, B can be measured with a meter rule, L can be measured with a meter rule, T can be measured with a vernier calipers, for example, because this is a thickness part. We should mention that. We should take those measurements in multiple different places, take the average to avoid for better results. You should also always mention that. And to have a good measure of the S value, we can have a set square placed over here where the linear side, or where the if you think of a so let me take this up. ফিগারটা দেখতে কেমন হবে সেটা আমি একটু এঁকে দেখাইতে পারি, or you can actually think about it. I am telling you the possible points for this question. We can have a set square that should be placed somewhere over here. I mean, আচ্ছা আমি ছবিটা একটু আঁকি।
স্যার, সেট স্কয়ার দিয়ে আসলে ঠিক কি হয় ওটা একটু বুঝিয়ে দিলে ভালো হতো।
আচ্ছা দেখাচ্ছি আমি, হোল্ড আপ, দেখাচ্ছি, ডোন্ট ওয়ারি. I cannot select this. Why can't I select this image? Oh, so this is not selectable. Okay, we have snipping tool. Snipping tool helps.
Sorry, তখন কি আপনি বলেছিলেন like to hang the mass using a string?
Yes.
Like আমরা তো ensure করতে হবে আবার যে স্ট্রিংটা যাতে টট না থাকে। But টট থাকলে স্যার যে উপরে টেনশন এক্সপেরিয়েন্স করবেন একটা ম্যাচটা।
Now, the string should be taut. I mean, what I'm proposing is that let me draw. Let's say we can attach a screw with a spring somewhere over here. Let me use red, and that so we can attach this, and that metal wire should roll over this part and produce the hanging space over here. The advantage over here that should be that no matter how much this thing bulges, you would always have this contact point right on the edge of the plank, as the question demands. And also that's one thing. And you can attach as many as load as you can, and also you would have this surface free for measurement. That's what I meant. Rafid, বুঝছো?
জি স্যার, হ্যাঁ তখন স্যার মাঝখানে এসে আই ওয়াজ কনফিউজড।
হ্যাঁ ঠিক আছে, সমস্যা নাই। And what other thing that I mentioned is that we can clamp meter rule on its side so that it would bend less, so that it can work for our reference over here. So I can try to draw a rectangle maybe with a sharp line.
স্যার থ্রেডটাকে আমরা স্ক্রু দিয়ে আটকাচ্ছি?
Yes. So in your drawing, you can draw a meter rule that looks like this. That should be clamped on the left side. You can write it in your description. You can actually draw the clamp, which perfectly works, because
Sir.
it would not be hanging in thin air. Just a second. And we can use a set square in this manner. Set square use time একটু দেখায় নেই। মনে করো এটা হচ্ছে আমাদের সেট স্কয়ার, আমি এটাকে ঘোরাবো, ডোন্ট ওয়ারি। Okay, we can use the set square. We can bring about the set square over here, touching this side, and slide it over here very carefully so that it does not essentially touch the apparatus setup. We are going to bring it really close, but we're not going to touch the apparatus setup to take a proper measurement of this thing. So our measurement should come from this region, and this part is over here to make sure that it is all perfectly vertical. That's one of the purposes for the set square. নিথিলা দেখো বুঝা যাচ্ছে কিনা? সেট স্কয়ারের কাজটা হচ্ছে প্যারালাক্স অ্যাভয়েড করে as close as possible রিডিং নেওয়া।
স্যার মেজার কি আমরা সেট স্কয়ারটা দিয়েই করব?
ইয়া,
আচ্ছা স্যার।
মানে এই সাইডটার পারপাস হচ্ছে টু মেক শিওর ইটস পারপেন্ডিকুলার টু অ্যাভয়েড এনি অ্যাঙ্গেল ভ্যারিয়েশন, আর অ্যাকচুয়াল লেন্থটা আসবে হচ্ছে এই সাইড থেকে।
হ্যাঁ স্যার বুঝেছি, থ্যাংক ইউ স্যার।
আবিয়াস কি জন্য বলতেছিলা?
Sir, I suggest that instead of doing this, we can just take two lengths and minus them to find S, like from the ground. There's S0 minus S1, and you can find the final S value from that.
Yeah, that can also work. That can also perfectly work. So before applying load over here, we can measure the length from the ground, exact height of the ground of this P point, and then after
Yes, sir.
loading, we can also measure the height from the ground as well, and we can subtract those two heights to get the value of S. Yeah, that's also very much achievable laboratory ways. Yes, you can also write that as well. ওটা লিখলে তোমাকে দুটো মিটার রুল আঁকা লাগবে না। You can just draw this up and you can just say that we do that, and তুমি একটা কাজ করতে পারো যে ইভেন্চুয়ালি তুমি যে ফিগারটা আঁকবা, আমি ফিগার পুরোটা এঁকে দিচ্ছি না because I want you guys to try use your imagination. হচ্ছে whenever you are going to draw this figure on your on the ground that you are going to label as your figure, because this is the bench, there will be a leg of the bench. You can always use break signs. One thing I would also recommend that whenever you're going to draw that meter rule, one good thing can be, let's say this is your apparatus setup, you draw the meter rule over here. Just beside the meter rule, prefer to draw a set square on your figure, just to show the examiner that you know that a set square is relevant in this experiment, because we want to avoid parallax error. This always helps to give the examiner a good idea that you know your shit. So this is pretty awesome. From an examiner's point of view, it's good. So you can include draw the set square over here, and you don't have to label both the heights h1 and h2. You can write about those in your diagram. I mean, this is easy, in my opinion, this is easier to write about than draw. That's why I'm not proposing to write two different heights. Or if you want to draw draw this height, and you can label two different heights. Let's say one from here, from resting position without the load h1, and then another one from this corner with the load, and after it comes to equilibrium, it's not oscillating or it's not giving random reading. So you have another value h2. So if you want to label them, you can also label them. No big deal. Be my guest. Yes, Shubhro.
স্যার আমি বলছিলাম কি স্যার, আপনি তো স্ট্রিং দিয়ে ম্যাচটাকে ঝুলিয়ে রেখেছেন, তাই তো?
That's what I'm proposing.
কিন্তু আপনি কি ওটা কি লাইক কোন টেপ ইউজ করে তাহলে ইয়েতে লাইক মেনশন করতে হবে না আমাদের যে কিভাবে আর কি স্ট্রিংটাকে ইন প্লেস রাখতেছি?
I said I used a spring that is connected with a screw. That screw would be screwed inside the wooden piece. That's why I started the string from here. This is where the screw is bolted or screwed on the wooden piece, and the string wooden metal wire rolls over the wooden plank onto the edge.
স্যার স্ট্রিং মানে স্ক্রু যদি ইউজ করি স্যার, তাহলে আবার ম্যাচের আবার ভ্যারিয়েশন হয়ে যাওয়ার কথা না?
What I explained is that the amount of M, capital M, that we'll be using to actually perform this experiment would be coming in kgs, because we would be requiring significantly large amount of mass to actually have any measurable deflection of a wooden plank that we are dealing over here. So one thing that we can do is that we can consider that we can measure the mass of this total hanging mechanism and add it with our capital M, which is going to be our added mass. That can be one possibility that you should include, or you can say, or you have to say that the M is too, so really large, so we can consider the mass of the hanging mechanism negligible for the experiment. That can also work.
Yes.
Sajid, did you say any question? No, no, no. Acha. So that's these are the experimental procedures that I can think about, and every reading should be repeated and recorded and averaged to have a better reading. We should have at least 6 set of reading, and then comes the manipulation of the equations. That it says that আচ্ছা, so এই equation এর আমাদের independent variable হচ্ছে L. This is something that we're gonna change on our own, and our dependent variable is S. So we're gonna say that our control variable would be the amount of mass that we're using for hanging, and also we'll be using identical wooden strips for all the readings, or really identical or same wooden strip for all the readings. Identical strips essentially makes your B and T as your control variable as well. It is very important that we mention the word identical or made from the same material, because we are trying to measure the Young's modulus of the wooden plank. So unless you have identical pieces of wood, it would be pretty difficult for us to have an uniform value of wood. I mean, you cannot use two different species of wood which would have different grain density or other properties, so that you will have different type of values. Your graph should give you a kink or something like that. You wouldn't want that to happen. So we should use identical piece, or if possible, we should use the same piece of wood for the whole experiment. But what is really important, what we should also write as a precaution, that after taking every reading, we should always check that after when unloaded, the wooden plank did come to its original alignment, or it did become horizontal. We can check it with a spirit level. We can check it with a meter rule, that the whole thing came back to its original shape, so that the next reading can give us a proper reading. Because you cannot do this experiment where the plank goes beyond the elastic limit or the limit of proportionality, because you can see over here this equation is a perfectly linear equation, y equals to mx, or so that's sort of an equation, so we do not want that to happen. So this is a type of a precaution that we can talk about. Other precautions will involve is that we should choose a wooden strip that does not have so much thickness, or we should choose such a thin piece of wooden strip that has enough flexibility, so that we don't have to work with a very large amount of M. I mean, if you choose let's say 1 inch or 2 inch size thickness of wood, the amount of mass that you might have to load to actually achieve any observable bending can be in terms of 10 or 20 kgs worth. So the thickness of the wood should be small enough so that the experiment can be easily doable. That's one important factor. The other important factor is that because we are working with hanging loads, and the wooden plank might break and loads might fall onto the ground, so you should always wear protective shoes. And because there is a question, because I'm involving over here metallic wire which is in tension. So if in some cases this wire might also break if you are not projecting your experiment properly, and a tension wire which breaks under tension can actually shoot itself like a stirrup in any direction. So that's also another problem that you can have. So you should always have protective goggles, or you can say that this whole experimental setup should be covered with protective shielding. Whole apparatus setup আমরা protective shielding দিয়ে cover করে দিব experiment করার সময়. You can also mention that. That's pretty important. I mean, the human safety part is really, really important. What else? There is no time measure. Then comes the part of the equation manipulation. So we have to talk about how can we use this equation. So what the best way is that we're gonna collect all this data, and then we're gonna in our table we're also gonna include the values of L cube. Then we're gonna plot a graph of L cube versus S. L cube versus S. If this plotted graph is a straight line that passes through the origin, then we can say that the given relationship is valid. And in that case, let me write. This equation is given by E equals to 4mg L cube. তার মানে হচ্ছে আমরা যদি এটাকে y equals to mx ফর্মেটে লিখি, we can write this at E equals to, should I subject L cube? কোনটাকে সাবজেক্ট করলে ভালো হয়? এখানে আমাদের ইন্ডিপেন্ডেন্ট ভ্যারিয়েবল হচ্ছে L। আচ্ছা, S কে সাবজেক্ট করলে ভালো হয়। এখান থেকে
S হচ্ছে independent variables.
হ্যাঁ, S কে যদি সাবজেক্ট করি, I'm gonna get, let's say on the right side I'm looking for L cube, so L cube would be here. এখানে আসবে হচ্ছে 4mg E B T cube. Yes. So if we plot a graph of S versus L cube versus S versus L cube, then we're gonna get a straight line that passes through the origin, which proves the relationship. And the gradient of this graph is equals to this part. We can replace the value of M from our earlier measurement. B and T
sir.
we also measured and placed from the from the measurements. And ultimately we can calculate the value of Young's modulus E. So এখান থেকে তোমার E টা হিসাব করে দেখাইতে হবে. So you have to give this writing that gradient equals to 4mg divided by EBT cube. Therefore E equals to হচ্ছে 4mg divided by gradient into BT cube. So from this equation we can calculate the value of the Young's modulus of the wood. So এটুকু পর্যন্ত তোমাকে বলতে হবে। হ্যাঁ বলো শুভ্র।
স্যার আমি বলছিলাম আমরা যদি S ভার্সেস L কিউব গ্রাফ আঁকি ইনস্টেড অফ S ভার্সেস L, তাহলে কি আসলে রিলেশনশিপটা মানে ঠিকভাবে দেখানো হবে?
না, রিলেশনশিপ ঠিকভাবে দেখানো হবে না, because if you plot it according to the equation, if you plot a graph of S versus L, you're gonna get a curve. From a curve, proving a relationship is pretty difficult. You would have to take at least 3 set of reading, measure out their individual gradient, and then again try to find out some relationship of those gradients. So we don't usually ever do that. If the equation itself, না S versus L এর রিলেশনশিপ দেখানোর মানে এটা না যে আমাকে S versus L প্লট করতে হবে। Showing a relationship between S versus L can come in any different format. For example, a relationship between, let's say, the resistance of a wire and the diameter of the wire is given by R proportional to 1 by D square. তুমি R proportional to 1 by D plot করলে কোনোদিনই এই রিলেশনশিপ লিনিয়ার দেখাতে পারবে না। And our aim is always to plot our graph in such a way so that we can always come up with linear graphs. This is very important.
Y equals to mx plus c format.
Y equals to mx plus c or y equals to mx by default if there is no plus c. Yes, that's always our aim.
বুঝতে পারছি স্যার।
Arnav, বুঝা গেছে? You propose a question. It's a nice one. Have a
Yes, sir. Good.
So let's have a look at the mark scheme and try to figure out what are the stuff that I missed and what are the additional stuff that we could possibly also write over here. This is MJ 1951.
স্যার
Yes.
ওরা তো মার্ক স্কিমে অ্যাডিশনাল পয়েন্টস এর কলামটা সবার লাস্টে দেয়, বাট আমরা যখন অ্যানসার করব ওই পয়েন্টস গুলো তো আমাদের অ্যানসারের ভিতরে আগেই ইনক্লুডেড থাকবে না?
Yes.
আচ্ছা স্যার, মানে লাস্টে প্রিকশন দিয়ে শেষ করব।
হ্যাঁ, তুমি লাস্টে প্রিকশন দিয়ে শেষ করতে পারো অথবা লাস্টে তুমি ক্যালকুলেশনের পার্টটুকু দিয়ে শেষ করতে পারো। মানে যেটা হয় কি, মানে ইটস নট এসেনশিয়াল যে তোমাকে একটা প্রপার সিকোয়েন্স অফ রাইটিং মেইনটেইন করতে হবে। ফর এক্সাম্পল তুমি মনে করছো প্রথমে তুমি ডেটা ভ্যারিয়েবিলিটি গুলো লিখলা, যে কোনটা কি, কোনটা কন্ট্রোল, কোনটা কি বলে ইন্ডিপেন্ডেন্ট ভ্যারিয়েবল, কোনটা ডিপেন্ডেন্ট ভ্যারিয়েবল, কোনটা কন্ট্রোল ভ্যারিয়েবল, এই কটা জিনিস লিখলে লেটস সে প্রথমে। তারপর তুমি হচ্ছে মেথড অফ ডেটা কালেকশন লিখতেছো, যে তুমি অ্যাপারেচার কিভাবে করবা, কোনটা কোন মেজারমেন্ট কিভাবে করবা। এখন ধরো কোন স্টুডেন্ট ওই মেথড ডেটা কালেকশনের মাঝামাঝি কোন জায়গাতে দুই একটা রিলেভেন্ট প্রিকশন লিখে ফেললো, আর ওইটার মধ্যে তাদের 2-3টা অ্যাডিশনাল রিলে চলে আসলো, দে গোনা বি ক্রেডিটেড ফর দোজ অ্যাজ ওয়েল। দ্য ওয়ে এক্সামিনার্স আর গোনা মার্ক ইউ, সেটা হচ্ছে মনে করো হচ্ছে যে এখানে যে সিম্বলগুলো দেওয়া আছে, ফর এক্সাম্পল এই যে এখানে, সো দিস ইজ ডিফাইনিং দ্য প্রবলেমের হচ্ছে 2টা মার্ক। তারপর মেথড অফ ডেটা কালেকশনে কিছু মার্ক আছে। সো এই মার্কগুলা যে সকল জায়গাতে এক্সামিনাররা পাবে, ওই সেন্টেন্সের ওই জায়গাতে তোমাকে এক্সামিনার ওই মার্কগুলা দিয়ে যাবে। ফর এক্সাম্পল মেথড ডেটা কালেকশন যদি তারা এম দিয়ে লেবেল করে, আই এম নট শিওর হাউ দে লেবেল দ্যাট। So let's say they're gonna give M1, M2, M3, M4, M5. So if you don't get total 6 marks, then there are gonna be 5 M's which is you got all the marks, or those are the all marks for data collection. Then if there is a method of analysis, if they mark it for A, then in places where they find those analysis information, they're gonna mark you in those sentences. Similarly goes for D, the D1, D2 as well, because they are marked in a very specific sequence in their mark scheme. So if they find, let's say, this additional detail first, then they are gonna mark, and in that sentence they're gonna give you D2. D2 means that you have scored the second additional detail. Then if they find out that repeat S measurement for each L, unloading and loading step on average S, if they find it somewhere else, then they're gonna give you that D6. So then eventually they're gonna count all those marks that you have scored, and they will give you a total mark on 15.
আচ্ছা স্যার।
So let's have a look at this thing. Marking the পড়ো সবাই।
স্যার
কি ভাই বলো।
স্যার T5 এর বুকলেট কি কালেক্ট করা যাবে?
বুকলেট প্রিন্ট করা হয়েছে, বাইন্ডিং করা হয় নাই, প্রিন্টিং এখনো শেষ হয় নাই। আমি মার্কস আমরা প্রিন্ট করতেছি, পেপার মানে কোশ্চেন পেপারগুলো প্রিন্ট করা প্রায় শেষ। আর 2 দিন সময় দাও।
ও আচ্ছা,
টাইম
ওকে স্যার।
প্রিন্ট করা তো ভেজাল না, প্রিন্টটাকে অ্যাটেন্ড করা হচ্ছে ভেজাল। প্রিন্ট কমান্ড দাও, তারপর হচ্ছে কিছুক্ষণ পর কাগজ আটকায়, সেই কাগজ বের করো, কারণ হচ্ছে প্রিন্টার ওভারহিট হয়ে যায়। তারপর হচ্ছে আবার হচ্ছে আউটপুট বিন ফুল হয়ে গেলে প্রিন্ট হয় না, একটু বড় কাগজই ফিল করো।
হ্যাঁ স্যার, এটা হয় অনেক সময়, ভিতরে কাগজ আটকে যায়। ঠিক আছে।
The printer is not smart enough to solve it on its own. So, আচ্ছা আমি করতেছি, I'll let you know.
স্যার আপনার প্রিন্টার কি এইচপি?
হ্যাঁ, এতদিন তো ক্যানন চালাইতাম, ক্যাননের উপর একটা এখন ডিসকাউন্ট হয়েছে, এখন এইচপি কিনছি, এইচপি M404 DW।
ও
ইটস নাইস, বাট সব প্রিন্টারে যে সমস্যা থাকে, কাগজ আটকায়, সেই সব সমস্যা ওখানে আছে। দেখো এখানে বুঝা যাচ্ছে কিনা, বুঝা না গেলে জিজ্ঞেস করো, এনিথিং। So there should be a way for fixing the strip. We need clamp, load shown touching at point P. So touching at point P, that's the important bit. So how would you place exactly at the point P? Touching that point P, that's a bit difficult to have. For example, the method to attach the load to strip, example, use glue tape attached with a hook and a string. That's essentially what they said. I did not read this mark scheme, but that's the first thing that popped in my head. Happy for myself. Use a ruler to measure L and S. Use a balance to measure M. হ্যাঁ, এটা বলতে হবে। Additional লিটগুলো পড়ে দেখো, if any of the part that doesn't make sense or if you feel that needs some additional discussion, we'll go for that. D3 is the point, clamp tool vertically to measure S, where we have to talk about for this positive, clamp tool vertically to measure this. However, if you go for this one, that you place a horizontal ruler on top of this thing along with the bench as well, and use a set square, then you also get that mark, because using a set square makes sure that your measuring alignment is perpendicular to the is perfectly vertical. So this or this, either way you score that mark, because they pretty much serve the same purpose, the vertical measurement of S.
Sure, in both the cases for the ruler আমাদের তো একটা stand and clamp show করতে হবে।
You will always have to show stand and clamps for equipments which are supposed to be held by stands and clamps.
They can just float around.
In all figures, this is mandatory. Don't show floating equipments. আমি এখানে একে দেখাইছি floating equipments because I wanted you to give an idea for what you're supposed to draw, but I didn't draw the full figure. I want you kids to try it. Showing you the full figure actually helps you to think less. I don't want that to happen, but you should always show clamps. তুমি মিটার রুলের সাথে ক্ল্যাম্প দেখাইতে পারো, বাট সেট স্কোয়ার সাথে ক্ল্যাম্প না দেখালে সমস্যা নেই, বিকজ সেট স্কোয়ার মেজারমেন্ট ইউজুয়ালি we're going to have the meter rule hang by the clamp, and then we're going to hold the set square by our hand and take the measurement at that instant, then we're going to let go of the set square. So set square ke clamp diye dekhano dorkar nai, but meter rule stuffs which are hold in position, fixed position, they should be always shown by stand clamps, always. You can simply draw one stand and multiple clamps coming out of it. Clamps can be as long as you need. So the design of the experiment can be slightly, what can I say, out of the world, or your stands might appear to be, overachieving. That's all right, but stand clamps must be there. বুঝছো কি বলছি?
জি স্যার।
স্যার মানে উড পিসটা তো স্যার স্ট্যান্ড ক্ল্যাম্প দিয়ে অ্যাটাচ করে রাখবো আমরা, সো দ্যাট ইট ডাজন্ট মুভ,
না,
রাইট?
উডেন পিসটা আমরা স্ট্যান্ড ক্ল্যাম্প দিয়ে অ্যাটাচ করবো না। উডেন পিসটা আমাদের বেঞ্চের সাথে আমরা জি ক্ল্যাম্প দিয়ে বা অনেক হেভি কোনো ম্যাচ দিয়ে আমরা এখানে লেফট সাইডে অ্যাটাচ করে রাখবো। দ্য রাইট সাইড শুড বি ফ্রি।
তাহলে স্ট্যান্ড ক্ল্যাম্পটা কিসের জন্য?
স্ট্যান্ড ক্ল্যাম্প লাগতে পারে হচ্ছে, আমি যে এই অ্যাপারেটাস সেটআপ যেটা দেখাইছি এখানে, আমি দেখাইছি হচ্ছে যে আমি এই মিটার রুলটাকে আমি উডেন পিসের উপরে অন দা থিন সাইড আমি এটাকে ক্ল্যাম্প করে রাখবো। দ্যাটস হোয়াট আই প্রপোজড। However, if you don't do that, if you use a measurement from the ground, like with a meter rule like this, এই মিটার রুলের সাথে তোমাকে অবশ্যই একটা স্ট্যান্ড দেখাইতে হবে।
ওকে স্যার।
Sure.
Sir,
Yes.
if we show the clamp and set square on the diagram, do we need to mention it in the text?
No. Stand clamps don't ever need to be mentioned in the text. Stand clamps must always show up on the diagram. Rule of thumb. The reason the examiners want the students to have stand clamps is because sometimes it's pretty easy to represent show equipments on the figure, but if the students do not show stands and clamps, then there is a possibility that the student actually did not understand how this whole thing is supposed to work out. So that's why since 2015, I believe the NP all the P5 mark schemes that the examiners pretty much made it mandatory that if the stand clamps are not shown in the figure, then they're going to be losing mark on the experiment. Showing stand clamps gives the examiner the confidence that the students actually understands how the equipment is going to be arranged. So that's important bit, an important bit. বাকিগুলো পড়ে দেখো, কার কোনো কোশ্চেন, or we gonna move on to the next one? We do have quite a good number of proposal.
Sorry, is there a long queue of questions?
Bolo.
Is there a long queue of questions? Is there a long thing you have to go through before I give a proposal question?
বুঝি নাই।
আমাকে কি অনেকজন জিজ্ঞাসা করেছে স্যার, I wanted to propose a question from the question paper.
Yeah, you can propose a question paper in the messenger thread. Arnav proposed some problems that I think he attempted. So this is the first one that we picked up from his list. This is the first one. Then we have this one. Yeah, this is a good question. Helmholtz coil.
হ্যাঁ স্যার, আমারও প্রবলেম সেকেন্ডটাতে।
We can pick this out. So
This is about a Hall probes.
This is sort of like, it's like a Helmholtz coil. We have two circular coil placed side by side. Yeah, I'm going to talk about in detail about how to operate this question. So we're closing this one and we're moving on to this one. May June 1452.
স্যার এখান থেকে একটা কোয়েশ্চেন ছিল যে লাইক স্যার
বলো।
যেখানে লিখেছিল like we can use a plumb line to ensure that it's vertical. তো এখানে plumb lineটা কেমনে ইউজ করা যায়?
Plumb line can be used in place of a set square. In place of set square, like একে দেখাচ্ছি আমি, hold up. Let's say you have this setup, okay, and then you want to measure the verticalness of this apparatus setup. এটা এখানে দেখাচ্ছি, don't worry. Let's take this out of it. We can use a vertical plumb line right on this edge from this point, and there should be some heavy mass underneath to make it a plumb line, and then take the measurement along this line, or you can use a set square. Let's say you can use a set square in touch with the plumb line. For example, আচ্ছা এই orientation তো ঝামেলা হইতেছে, এটাকে vertically flip করলে না। Yes, let's say you take the measurement like here. So তোমার meter rule হচ্ছে মনে করো এই জায়গায়। Let's say your meter rule is over here. You hang a plumb line from a certain vertical point with another support from the stand, and you make the plumb line perfectly go on the side, and you use that plumb line to make your set square aligned, and then this set square side is gonna go over your meter rule, and you can take the reading from this edge on the meter rule, so you don't directly use a set square. That's also another way. বুঝছো?
স্যার প্লাম
sir,
লাইন
got it.
দিয়ে কিভাবে বুঝলেন দাঁড়ান? How did you?
Our aim is to measure this S vertical to the ground. So we do not want any angle to interfere our measurement for any of our measurement. So to avoid that, we are hanging a plumb line. Plumb line is basically a string which has a heavy mass loaded underneath, and we are hanging it from a specific point in such a way so that it is touching this edge of this thing, nearly touching, not essentially touching, because touching might cause some friction, which brings up some additional variable to our experiment. So we're going to place it pretty close, and everything has to be stationary, not oscillating, not moving. And then we can use the set square aligned with the plumb line, and the other side of the set square can give us the reading where the meter rule might as well be located somewhere over here. So you can take this reading from here, and then you can move it all the way. Then you can move the set square all the way up to this point to take the second reading. That can work, because in that case you wouldn't have anything over here. This horizontal level would be unlabeled for you. This is applicable for the scenario where you don't have this. But if you have this pretty much too easily achievable. You just have a reference line, then you use the set square to directly measure how much drop it is making.
মানে স্যার রুলটা উপরে হরিজন্টালি থাকলে তাহলে লাগবে না প্লাম লাইন দিয়ে চেক
No, because once you have the rule horizontal to your setup, you are basically defining this dotted line by the edge of this ruler. That way, all the measurements come to much too easily, in my opinion. And set squares are always labeled with a millimeter scale, so you can take the direct length measurement from the set square as well. In this case, the set square is performing this set square over here is serving you as a meter rule. It's also serving you as a parallax or avoiding mechanism. Both of them at the same time works. বুঝছো?
স্যার
Yes.
সেফটি প্রিকশন ইউজ স্যান্ডবক্সটা শুধু বললে হবে নাকি রিজনও বলতে হবে?
না, রিজন বলার দরকার নাই। না আসলে
আন্ডারলাইন করে দিস
রিজন বলতে হবে। রিজনের ইয়াতে আন্ডারলাইন করে দেওয়া আছে। You have to give the reason as well. Use sandbox to avoid sudden fall of the load, and wear goggles in case of the string. Yeah, you have to give the reason, because the reasons are given with underlines, which means they are essentially needed. বুঝছো?
Yes, yes.
So let's pick up the next question. I'll discuss this, and then I'll take up one proposal from Abias. Don't worry about that. So this is Majun 1452. Let's go for that one. Majun 1452 should be somewhere over here. There you are. Eta ki? Na, eta na. Similar question. Eta 117 e chilo. We might as well also pick this up right after that, because it's a similar question. Achha, anyway, let's go for Majun 14. Mithila, did you propose this one or the other one? Because they both looks pretty similar.
Sir, this one with the X on it.
This one, but on a proposed
Yes, sir. হ্যাঁ স্যার, আমারটা ছিল ওই সেকেন্ডটা আর কি।
Why can't I do page up? আচ্ছা, আমি সিলেক্ট মোডে চলে আসছি। I have to select দাঁড়াও দেখতেছি imagine 14 you might wonder যে আমি যদি এমনি করে পেজ নাম্বার বাই করি তাহলে আর ইন্ডেক্স বানানোর মানে কি হলো I have no clue এখানেও x আছে
স্যার এইটা না
আচ্ছা সমস্যা নাই দুইটাই খুব একটা মধ্যে খুব একটা ডিফারেন্স নাই we can pick up both of them don't worry imagine 1452 question number 1 imagine 1452 question number. Okay, let's have a look at this question. This figure is looking a bit wobbly because there are a lot of parallel lines and the pixel of your of my display is making some weird pattern over here. Is it same for you as well?
Yes, sir.
Some patterns over here. Anyway, let's have a look. Two identical coils are connected together and arranged as shown in figure 1.1. So we have two coils going around. They are connected by the same wire, wrapped around apparently a helical ribbon. It's not a ribbon. What is this thing called? Bobbin? No. Circular arrangement, whatever. The coils are in the vertical plane and parallel to each other. When the coils are connected to a power supply, there is a magnetic field between them. It is such that the magnetic flux density B of the field at point X is related to the radius of the coils by the relationship B equals to 0.72 mu naught Ni divided by R, where N is the number of the turns of the coil, turns of each coil, I is the current in the coils, and mu naught is the permeability of free space. Okay, this is an laboratory experiment that uses a Hall probe to test the relationship between B and R and determine a value for mu naught. You should draw a diagram on page 3 showing the arrangement of your equipment on your account. You should pay particular attention to blah 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 blah. Okay, so we are trying to figure out a relationship between B and R. So B is our independent dependent variable, obviously, which we should measure with the Hall probe. R is the independent variable which we are going to vary for different coils, and we should have 6 different size of this. What can I say this setup is? I mean, what is this thing called? Bobbin? Is this a bobbin?
So I'd call it a ring.
Frame? We can call it a frame. Yeah, it's a simple word, frame. The circular frame. Yeah, that works. আচ্ছা এখানে important informationটা হচ্ছে যে these two coils have to be identical. That's the first part. Two identical coils. So one of the first thing in your experimental setup, a very important or elaborate discussion should be there that what steps did you do or what mechanisms did you follow to make sure that the coils are actually identical. So that's a pretty important bit. That's the first one. Then it says that the coils are in vertical plane and are in parallel to each other. So you have to make sure for a way that these two coils are in the same spherical, same circular or arrangement, which means that they are both vertical with the ground and they're both parallel to each other, which means to make sure that they are parallel to each other is pretty simple, that you can simply measure their distance in between different places. If those distances are perfectly equal to each other, then you have that thing working for you. Or you can essentially make a spacer or you can cut up a piece of object, a wooden piece or styrofoam, which you can use for your measurement in different places. So you can, if any of the, so you can use a reference length so that they are both equal on all the locations before you start to take your reading. And also, what is also quite important is that because we are going to place them to make sure that they are vertical, that we have to use pretty long set square, or we have to use a set square that is attached with a meter rule to measure in different parts of these circular sections. What I mean is can be drawn to something like that. Let me delete these things. For example, let's say this is one face of the circular coil. Let me choose a bit more thickness. This is one face of the circular coil, and let's say this is the table that you are placing it on. So let's say this is the table that you are placing it on. So one of the important thing that is that can go on is that you might have to use meter rule because a set square is not supposed to be this much long. That's where the meter rule comes in. So this is the side view maybe, and if I draw the face view, let's say this is the ground, and I'm just showing you one of the circular structure. So let's say this is the face of the circular structure. So this is the place where the wires are all connected. So this is the actual, this is onto this thing, you have the wires wound around. So you can use a meter rule. Let's say I'm going to draw the meter rule with blue. So a meter rule can be placed beside this thing over here, and that should be accompanied with another set square, which to make sure that this thing is perfectly vertical. The reason I'm using a meter rule and set square as well, because a set square might not have as big of a side as the diameter of this thing. It might not. So having a meter rule can actually help to make sure that the whole thing is perfectly vertical. And this thing should be checked in multiple different places. For example, if I represent this whole thing as a single line, let's say this is the setup where we have the meter rule and also the set square. This thing should be checked in multiple places. For example, let's say you check over here, over here, over here, over here, in multiple different places to make sure that the entire coil is perfectly vertical. Not only in one place, because if you only check it at the middle, it might also happen that it might have some axial dissymmetry. So we should be checking it everywhere, and also the space between the two coils should be measured before you do your set of reading. And obviously, for each reading, you should take multiple readings, and you should do the average of the B value. B কেমনে measure করব সেটা একটু পরে বলতেছি, going for the B measurement a bit later, but you should definitely have that over here. That's what I think. And also to have, also another thing that is pretty important is that we are trying to have a measurement of this whole apparatus. So we're gonna flow in some current over here, and we're gonna be measuring. Hold on, just a second. Hold up a moment. Sorry, I had to order some stuff before the shop closes for the night. Okay, so we have to have a way to control this current. Have a look. We are trying to find out a relationship between B and R. Try to get this point. So N is a control variable, which means for each of our experiment, the number of turns in this coil should be exactly same. For all of our coils, we should have at least 6 different radius of coils to have 6 different reading, or if we can achieve more, then also good, no big deal. But there should be coils available to us. There should be a circular structure available to us which have 6 different diameters. That's one thing that you have to mention. Somehow we have to achieve that. And also the number of turns in each of these individual coils should be exactly same. The current that will flow through each of these coils should be also exactly same, because current is in this case is also a control variable. Now, how can we control the current in a circular circuit? Well, obviously what you have to do, you can draw a two-dimensional version of this figure. You should, and you should connect DC supply over here, because we are not working with it. Nowhere in this question it says an AC supply. It's a DC supply. So we're gonna connect a DC supply over here. Along with the DC supply, we should have in series a variable resistor and an ammeter, and obviously a switch. That's the workable circuit. The purpose of the ammeter is to measure the current so that you can observe the value of the current. The purpose of the variable resistor is to increase or decrease the resistance of the current, resistance of the circuit, so that that current can be maintained for at a fixed value throughout all of our apparatus setup. This is very important, because we have to keep the current constant. So to make sure that the current is constant, we need to have a way to view how much is the current, that's where diameter comes in. Then we need to have a way to control the value of current, that's where the variable resistor comes in. So all of these things should be connected in series in a workable circuit. Other things that is pretty important is that as the question as the figure shows over here, that the coils are not overlapping. So we should mention that as well, that we wrap the wire around the circular frame in a way that they don't overlap, and to make sure that they stay in that manner, we can apply masking tape, or you can say normal paper tape. Masking tape is pretty good. We can use masking tape on top of them so that the coils are perfectly in their orientation before you start doing the experiment. And also in this question, the question nowhere it says that what should be the in-between distance between them. We're trying to find a relationship between B and R. The in-between distance is nowhere mentioned, but for all of our apparatus setup, that in-between distance should be exactly same. So that's why I said that we should measure the gap in between and maintain that same gap for all the individual different coils, so that we can achieve identical reading without the physical variables. So if you ask me what is the independent variable here, the independent variable is the আচ্ছা আমি আরেকটা জিনিস বলি না, সেটা হচ্ছে how can you measure the magnetic flux density. We can measure the magnetic flux density by a Hall probe. You don't have to draw a full visualizing form of a Hall probe. You can simply draw a rectangular box that is and label that thing as a Hall probe in between your two coils. And to make sure that the Hall probe reading is perfectly accurate, we should place the Hall probe over here and rotate it around 3 different axes to get the maximum reading of the Hall probe reading. This is pretty important because in this case you have to understand that if you think about it, if I take this picture out, hold up. No. So if you take this picture, you have to understand that around these two coils, we are going to have identical coils, and it's important that they should be wound in the same way. What I mean is this: let's say this coil is wound in this manner, this coil should also be wound in the exact same manner. You cannot have opposite direction of wounding. That way you would be messing up the magnetic fields. These two things should produce a combined strong magnetic field. But if you think about it, the magnetic field lines over here should have curved behavior. They'd be entering from one side and going to the other side, irrespective of which is north pole or south pole. So it is very important that we place the Hall probe right at the center of these two things. That center is the center of the adjoining lines of these two circular coils, and it should be exactly at the midpoint. So there lies a pretty important question, that how would you specify where exactly should we hold our Hall probe? This is pretty important because these are hollow structures. So one of the things that we can do is that we can actually have them filled up with, let's say, circular boards, label their center, physically label their center by finding out the diameter with maximum distance measurement, and attach a piece of what can I say, and tie up a string from one center to the another center, and then mark the midpoint of that string to find out the exact midpoint of the center. Let me tell you what I'm trying to propose once again. I'm proposing thank you. So let me propose what I'm saying once again. Other than having hollow coils, we can have, if we introduce something over here, then the permeability of free space would be actually messed up. Here's one other proposition. Try to think about it. To find out this exact midpoint, which is basically located in empty space, what if we try to do this? We tie up only two strings, basic cotton strings, not metal strings. Let's say one from the very bottom to the top of this thing, and one from the very top of this thing to the bottom of this thing. These two strings should cross each other at a one point, right? Shouldn't they do this?
So can you repeat?
I'm trying to
Repeat
figure out a
for
way. Bulwan, you kids also think about it. I'm trying to figure out a way. How can we exactly locate the location X point where we should hold our Hall probe? This is a point that is in empty space. There is no physical reference for where we can place this exposition. What you can get from the figure is that this is supposed to be at the midpoint of the center joining lines of these two coils. But this, in your actual experiment, this would be a point with no physical reference. How can you find this exact location where you should hold your Hall probe? How? Think about it.
Sir, the distance of the radius from the table.
Yes, but so we place the Hall probe above that radius, and then that's for the vertical height. Okay, works for me. How about the horizontal alignment? How do you find the exact midpoint of that?
Distance between the centers of them.
So these are hollow coils. How do you get their centers? Or how do you even label them to work with them?
So not like their actual centers of gravity, like from, I'm saying from a side view.
So what I was thinking,
Sorry.
yes, Bolo.
How about attaching two cotton strings diagonally? So I suppose they're going to intersect at some point.
Exactly.
So we can come.
Yeah, beautiful. That's exactly what I was trying to go for in this my second mechanism. At first, what I was thinking that we can try to fill up this void with some physical cardboard paper, maybe cardboard or styrofoam, or let's say hardboard paper, and then find out the physical diameter, and then poke a hole through them, and then find out the physical center. That is elaborate, and pretty much that's something that I should not do, because the empty space should be empty, because what in our experiment we are trying to find out a relationship for the magnetic field strength where mu naught is used. Mu naught is basically the permeability of free space. So how effectively the magnetic field lines can pass through hollow space. So we should not incorporate bigger amount of magnetic difficulties. Let me put that way. I'm not going to use the word resistance because that can be a bit confusing. So let's say magnetic difficulty. So introducing a new medium might be a difficult thing to do. So one logical thing which can be pretty easily achieved, as Mugdho proposed, that we can connect two diagonal strings. For example, one string that is connected from here to from this point all the way to this point, and another one from here to here. These two diagonal strings should cross each other exactly at a point which should be basically the center of these 2 points. Do you get my point? And the presence of these two strings can be considered to be minimal or negligible, or even once we find our so you can consider that their effect to be minimum, that should be included in your in your description. Or another thing that you can do is that we can find out this location over here, clamp our Hall probe with the exact alignment, which means we are trying to place a Hall probe over here facing horizontally, which means let me show you, if I try to show you the actual Hall probe. Let me show you how a Hall probe looks like. Might as well be a good time to give you a physical view. Hall probe device. Showing us all these stuffs, but can we not find a Hall probe device? Sensor, current, animation, free energy, enter semiconductor, hole, metal, p-type. Application, classical, no. Wikipedia, electric field, circuit, resistivity, symbol, type semiconductor, DER POW, what is that?
Sir,
Hello.
এক্সপেরিমেন্টে যখন আমরা সার্কিট আঁকবো ওটা তো সার্কিট ডায়াগ্রামে দিয়ে আঁকবো, মানে ক্রস ফর বাল্ব এন্ড ডট ফর সুইচ, ওইটাই তো।
If you want to draw the side view, then you can, but if you don't, then you don't have to.
আচ্ছা স্যার, মানে স্যার রিয়েল বাল্ব আর সুইচ তো আর আঁকা লাগবে না
Bulb or switch মানে?
স্যার, মানে ওই যে সার্কিটটা যখন আমরা দেখাবো তখন কি আমাদের রিয়েল সুইচ বা রিয়েল ভোল্টমিটার আঁকা লাগবে, নাকি ওই সিম্বলস যেগুলা P4 এ ইউজ করি?
Perfectly symbol yakba. Every electrical symbol should be used as electrical symbols. Anything that you don't know how the electrical symbol should look like, you go for a rectangle and label that. Works. Battery,
Sir.
battery, resistor symbol, resistor, variable resistor symbol.
মানে স্যার ব্লক ডায়াগ্রাম মানে
Just to draw a rectangle in that place and label that diagram, that works. Achha, this is pretty much how a Hall probe looks like. So basically, apparently, this is how the Hall probe looks like. So this Hall probe, this is actually Hall sensor. This has to be connected with multiple other components to get the readings out of it. But this has a alignment that to work with. It is important that we should place the Hall probe. I mean, তোমার Hall probe এর যে ফিগার গুলো শিখছো, বই গেল, যদি দেখা যায় এরকম করে মনে করো এটা হচ্ছে একটা হল স্ট্রিপ। এই হল স্ট্রিপটাকে আমাদের মেক শিওর করতে হবে দ্য স্ট্রিপ ইজ পারপেন্ডিকুলার টু দ্য ম্যাগনেটিক ফিল্ড লাইন্স অফ দ্যাট লোকেশন, সো ফর ইট টু গিভ আস দ্য প্রপার রিডিং অফ দ্য ম্যাগনেটিক ফিল্ড স্ট্রেংথ। এখন this is why it is important that whenever we will be doing this thing, we can find out the exact midpoint of the we can find out the exact location of this X point, then place that Hall probe in that location, and clamp it in that position with stands and clamps, and then we can cut off those strings if that's about any hindrance for our measurement, and then we can redo the whole experiment. So finding out that position first, placing the Hall probe in that position, clamping it over here for a fixed orientation, and then we can get rid of the strings, and then you can go ahead with the experiment. You can essentially have the strings as well, because I don't think that those strings are going to propose any measurable amount of variation over here. And if you keep those strings for all of your data, I think that's pretty that can be pretty well done. Just a second. I'll give you a floor. Just a second. Another thing that just popped in my head is that we should always repeat an average for all the readings of the Hall probes for a single set of diameter of the radius of the coil. What is pretty important is that between taking these readings, we should always give some gap time. For example, let's say you take a reading for, let's say, 10 seconds, then you wait 5-10 minutes, or at least if we wait 5 minutes, and then we take the second set of reading for another 10 seconds. It's important because we don't want to heat up the coil and take messed up reading, because any single time we flow some current through an electrical circuit, it will always heat up, and heating up can give you different set of reading, which we don't want to have our problem, have our data messing up. Another important thing which I forgot to mention is that the wire by which we'll be winding all the coils should be identical. Well, it actually na bolleo hoy, it actually খুব একটা important না, but I'm not sure if that's going to be incorporated in the additional detail or not, because having the wires identical is not a big deal as long as we can keep the current same. I'm not sure having the wires identical would be important, but I would go for including that anyway, that we use wires from the same coil to have all the wire identical in all of our coils. বলো।
পজিশন সেট করার ব্যাপারটা আরেকবার একটু বলেন তো, মানে এক্স্যাক্টলি কি করছেন স্ট্রিং দিয়ে?
This
মানে স্যার আপনি ডায়াগোনালি দুইটা স্ট্রিংকে হচ্ছে একটার থেকে আরেকটার সঙ্গে অ্যাটাচ করে দিচ্ছেন। সো ইন্টারসেক্টিং পয়েন্টে হচ্ছে আমরা মিড পয়েন্ট পাচ্ছি। হ্যালো স্যার,
একটু ওয়েট করো স্যার।
precisely যেটা বলছো শুভ ওটাই। All right, I'm back. So that's what I did. Yes, the thing that I just do, we attach two pieces of strings diagonally to find out their correspond, which should give us the floating midpoint in the air. That's actually a word used in syllabus, just popped in my head. Floating point. So finding out this floating point can be a difficult thing, but we can essentially achieve this pretty simply by going for this mechanism. So these are the things that I can think of. Is there anything else that is important for this experiment? Acha, for this
স্যার
experiment,
সিআরও ইউজ করে
Hmm?
সিআরও ইউজ করা যায় ভোল্টমিটারের বদলে
we are not using a voltmeter for this experiment at all. Why is the voltmeter coming in? এই এক্সপেরিমেন্টের জন্য ভোল্টেজ তো মেজার করতেছে না। এই এক্সপেরিমেন্টের তো সিম্পলি আমরা ম্যানিফেস্টেশনের সাথে কারেন্টকে রিলেট করতেছি উইথ এ কনস্ট্যান্ট অ্যামাউন্ট অফ কারেন্ট। সো এখানে তো আমাদের ভোল্টমিটার লাগতেছেই না। সো this workable circuit, what you can connect with this workable circuit, let me just connect this one. For example, let's say you pull this up, show up a DC supply, show a switch, then show a variable resistor, and then connect it with an ammeter maybe. And this is the workable circuit that we're going to work with. এখানে তো voltmeter emergency না। বুঝছো কি বলছি?
হল প্রবের সাথে লাগাতে আমরা ভোল্টমিটার
Acha, the Hall probe is a digital device that will directly give you the magnetic field strength in its display. Pretty much like a tachometer or pretty much like an anemometer. You just place it up in the location, it's supposed to measure what it's supposed to, it will measure what it's supposed to measure, give the magnetic field strength in its display. আমাদেরকে ওই হল ভোল্টেজ থেকে আবার ফার্দার ক্যালকুলেশন করে I equals to NAVQ and রিপ্লেসমেন্ট করে আলাদা করে আবার হল মানে ম্যাগনেটিক ফিল্ড স্ট্রেংথ হলো আলাদা করে বের করতে হবে না। The Hall probe itself will give you the B value in its display altogether. বুঝছো?
হ্যাঁ
Something similar to like a, let's say thermocouple thermometer or something like a pyrometer. You might have seen pyrometer in a lot of cooking shows where they or even these days এই যে এখন যে করোনার জন্য যে টেম্পারেচার মেজার করে না, these are pyrometers. They aim that thing to our whole forehead at a certain distance, the amount of infrared radiation coming out that is measured very precisely, and that gives us the reading. So it actually measures the amount of infrared radiation coming out of our forehead, converts that information with appropriate logarithm algorithm into temperature. So you don't have to calculate how much radiation is coming and what's the internal constants and everything. It will just do the purpose for us. So don't worry about that.
স্যার আমরা যদি হল প্রবটাকে ক্ল্যাম্প করি তাহলে কি এটা চেঞ্জ হয়ে যাবে পারমিটিভিটি অফ ফ্রি স্পেস?
Well, that there would be an included hindrance because of the existence of the Hall probe material. But if you keep that same for all of your reading and all of your data throughout your experiment, that will include a fixed error, or I can say it will induce a systematic error. I think we can have that because we cannot do without. Because if we want to measure the Hall probe without, I mean, here's the deal. Hall probe টা তো এখানে ভাইসা থাকবে না, তাকে হাত দিয়ে ধরে বা ক্ল্যাম্প দিয়ে ধরে বা সুতা দিয়ে উপর থেকে ঝুলায় কোনো না কোনো ভাবে হল প্রবটাকে ওখানে সিচুয়েট করা থাকতে হবে so that we can actually measure the Hall probe's body, the plastic body, all the coils and everything that would also be incorporated in this location to produce a magnetic barrier for the to change the permeability of free space. I mean, you cannot use the Hall probe in that location to measure the magnetic field strength without actually having the Hall probe in that place. That's not how it works. So this is an unavoidable, what can I say, hazard of the experimental quality that we have to bear with. Buchi will say.
Yes, sir.
So you can incorporate the stand clamp, or you can say that we're gonna hold it up with our hands, with very steady hands. That can also work, but I think that works. No other additional points comes in my mind. Can anybody else think of something else? আচ্ছা যে এখানে আছে ইম্পর্টেন্ট পার্ট হচ্ছে এখানে কন্ট্রোল ভেরিয়েবল, এখানে ইন্ডিপেন্ডেন্ট ভেরিয়েবল হচ্ছে রেডিয়াস অফ দ্য কয়েল, ডিপেন্ডেন্ট ভেরিয়েবল হচ্ছে the magnetic field strength B. The control variables is the number of turns in the coil, the current in the coil, the distance between the coil. This is very important. The distance between the coil is very important. All this is not mentioned over here, but this has to be kept constant throughout the experiment for this measurement to be appropriate. And eventually it says that design a laboratory student that uses a Hall probe to test the relation between P and R and determine the value of mu naught. So এখানে value of mu naught বের করা খুব সিম্পল। এই কোশ্চেনটাকে প্রুফ করার জন্য we'll have to plot a graph of B versus 1 by R, because R in this case is the denominator. So B, let me write, we're gonna have to plot a graph of, yes, Ashriya, you have something to say? So we're gonna have to plot a graph of B versus 1 by R. So that will be our graph, and eventually the gradient of this graph would be everything that is on the top. And এখান থেকে তোমাকে mu naught এর ভ্যালু বের করার একটা ইকুয়েশন দেখাইতে হবে. That can work, I believe. বুঝা গেছে? Let's have a look at the mark scheme to find out what they have to say about this, and then I can go for the identical question that I just found out right after that. This is Majun 1452. I might as well look at the S1452 on page number 218. Where is page number? 218. I don't know. R is the dependent variable, B is the dependent variable, where R, B. Acha, yeah, obviously, yes, please go ahead.
Sir, I was asking, when drawing the Hall probe in the diagram, do we have to show its correct orientation?
No.
As
You don't. You just draw a rectangular box, label it with a Hall probe, and draw necessary stand clamp or arrangement to keep the Hall probe in place. Stand clamps are important, and draw a rectangle to label the Hall probe. In the description, what you should write that we place the Hall probe in an orientation that it gives the maximum value of B by trial and error. We're going to place the Hall probe over here, rotate it in multiple different places, and eventually we're going to find out the orientation for which it gives the maximum reading of B. Because for the maximum reading, it is obvious that the magnetic field lines are passing perpendicularly to the Hall probe plate, metal piece. So you mentioned that in your description, but you don't have to give visual cues in your figure to go incorporate that information, because that would be pretty difficult to do. You have to draw three-dimensional figure. I cannot think of how to do that, but writing it in description is pretty easier, I think.
Another thing, sir, don't we need a voltmeter to measure the Hall voltage?
We are not going to measure the Hall voltage individually. The Hall probe itself is like a digital thermometer, or it's like a tachometer. It will do the reading and give you the output of magnetic field strength in the display automatically. It will not give you only the Hall voltage value, so that you have to go through some manual calculation by your own self to calculate the magnetic field strength. Hall probe will measure the Hall voltage within itself, use that Hall voltage to convert that into magnetic field strength, and give you that data on the display in magnetic field strength, Tesla.
I see, sir. So it's just pre-calibrated according to
yes.
built-in. The thing is, sir, we learned it a bit differently in school, where we measured the raw Hall voltage and calibrated manually and stuff.
That can be achieved if we really want the students to go through the experience of actually measuring the Hall voltage and make them do the calculation. There is some additional mark given for the calculation, but if you buy Hall probes, sensors, as I showed you, those come in like transistor shapes, or if you actually buy a Hall voltage measuring or Hall probe devices, they will come with the digital display as well. I couldn't find a figure, but I'm definitely going to find a figure, and I might as well post it in the channel later on. I didn't want to search it during the class time. Mugdho, you have a question?
Sir, do we need to mention how will we measure the number of turns on the coil?
We just count while we wound it. No, you don't have to mention it. I don't think you have to mention it. You just have to mention that we keep the number of turns constant while we wound the wire around the coil, for both the coils, for all the experiments.
Sir,
Yes.
connect Hall probe to voltmeter. এটা কেন?
কোথায় দাও এখানে?
Of course, sir. Methods of data collection.
Has a method of data. Number 3.
Third one.
This is disturbing. I did not read this, but apparently they are assuming us to go to the voltmeter. Why? Why?
It's kind of strange, sir, because like when we use a thermo,
I was wrong. Hall probes don't give you voltage magnetic field strength apparently directly. You have to have a way to calculate all of these stuff back into magnetic field strength. But that should be pretty difficult. If you have only access to a device like this, how do you get all of these different uh, constants to work with? You can measure the Hall voltage. Let's say you measure the Hall voltage. Good, beautiful. Then you have to convert the voltage information into B information. What are the constants and what are the variables by which you convert that thing? Would it come along with that transistor-like device?
it's proportional. Flux density is proportional to the Hall voltage, sir. So I suppose we just draw
Yeah, they are proportional.
proportional.
We can find out find out the relationship over here, but let's say well, here's the deal. I mean, here's what I'm thinking about. If we really want to calculate the value of mu naught, you know the exact value of B. Having a proportionality can help you to prove the relationship that, I mean, in place of B we can place V over here as a proportional value. Works for me. But if you want to calculate the mu naught, you know the exact value of B. How do you do that? Oh no, I was mistaken. It has to be connected with the voltmeter. So the Hall probe should be shown to be connected with the voltmeter. So if you need to show a Hall probe over here, let me try to draw it over here. So we might as well draw a rectangular box, label this as Hall probe. Let me do this. So this is a Hall probe. Hall probe. And we pull out two wires out of it in a place and connect that wire with the voltmeter. Trying it, this can work. Or you can connect it with the arrow. Apparently this is needed as per the Mars scheme. So Hall probe would not be an automatic device. It would make you do the calculation. But all those constants that you're supposed to know, would they come along with the Hall probe? I have no physical experience with the Hall probe, so maybe that's why I cannot explain this properly.
So Mark scheme at a point ছিল যে calibrate the Hall probe with a known magnetic field. So can we use proportionality to find out the magnetic flux density?
Use that kind of,
উপরে ছিল
calibrate Hall probe with a non-magnetic. Life is sweet. Oh, this is I mean, for a Hall probe to work, apparently okay, these are absolutely new for me as well. I either did not know this thing, or I totally forgot. My brain flashed this information. What they're proposing over here, I mean, this line makes a lot of sense. Is that calibrate Hall probe with a known magnetic flux density? What this essentially would mean is that you have to have the Hall probe, and you have to have a source of magnetic flux density in your availability in your lab, or from your teacher, that the teacher know the magnetic flux density directly by, and you'd have to calibrate that Hall probe with that magnetic flux density, fixed magnetic flux density value, so that you can use proportionality relationship to convert those individual voltage measurement out of the Hall probe into relevant magnetic flux density values. So you don't have to bother about all those constants, including the like N, T, Q, and I, and the number of charge carrier per density, thickness of the Hall probe, and everything. You don't have to bother about those. You can directly measure the individual magnetic flux density from your experiment by the proportionality. My question: where do you get a source that has a known magnetic flux density? Because if the magnetic flux density in its first place is supposed to be measured by a Hall probe, I mean, does this land on you from this outer space, or I mean, how do you get this?
So industrially things like in those CAT scan things, sir, they can vary the magnetic field density using.
But what I'm trying to get at, I mean, what is really important for you to remember in the back of your head, that you have to design an experiment that will be operated in a laboratory with laboratory available equipments. So you need to think of a way that you need to think of a thing that will have a known value of magnetic field intensity also available in your lab. I cannot think of a device like that. I have never bought one.
স্যার একটা ম্যাগনেট রাখলে কি হবে?
You have to know the exact magnetic flux density of that between the two poles of that magnet, which cannot change over time, which is highly impossible because Earth's magnetic field naturally, or the stray magnetic field around objects will always lower the magnetic field strength of a permanent magnet. A pre-made permanent magnet would never hold its actual magnetic field intensity intact unless you have a really sophisticated shielding mechanism around it for storing. This is difficult. Anyway, that's what the people want from you. So you have to connect the whole probe to a voltmeter CRO, the voltmeter to voltmeter or CRO, and then you have to calibrate the whole probe with a known magnetic flux density. I don't know where this comes from according to the Merck scheme, but this has to come from somewhere. And that comparison should give you the measurement of the B value so that you can eventually go on with the experiment. Let's have a look at these other parts. So precaution linked to the large heating of the coil is about switch off when not in use. Yeah, that's what I said, that we have to use the heat up the, we have to take reading and then wait for a couple of minutes and then take the second reading. I talked about the waiting, so I think that works. Switch off when not in use to avoid overheating coil. Do not touch coil because it is hot. Yeah, well, there are 3 different precautions over here, I think. Two different precautions, but they are given as examples, which means you can use other relevant applicable ideas as well. They're gonna credit you for that as well. Have a look at the additional detail. Use large current to large number of turns to create a large magnetic field. I did not say that. Use resistor to adjust the current in the ammeter to keep the current constant. I said that. Help over right angles to directional magnetic field, allow just to obtain maximum reading. Yes, I said that. Reason method to keep Hall probe perpendicular to the directional magnetic field. Example RX. Example use of set square, fixed to rule, optical bench or equivalent. Okay, I did not say that. Why perpendicular to the directional magnetic field? Asha, we said that we're going to measure for the maximum voltage and then we're going to hold it with a clamp. I think that can work. Fixed to rule. Fixed to rule is basically similar to clamping. I think that can suffice for that. Method to check the coils are aligned in parallel. So I said that we should measure the distance between the two coils in different places and make sure that they're exactly equal and hold them in places with clamps so that they do not change their distance over time. It's important that while you're doing the experiment, the coil should be properly clamped as well, because whenever you will start flowing current through them, they themselves will attract each other. So if you don't clamp them properly, the moment you turn on the current, they might actually get closer and your whole measurement might get messed up. So everything should be external problems to go through. Then method to repeat experiment with Hall probe reversed and average. This is pretty important. Reversed and average means that if you have for one specific element, if you get a positive reading, positive voltage, then for the exact 180 degree rotation, you should get a negative voltage of equal value. Now, if you so to have a much more reasonable to have a more accurate data, we can always do that. This is one easy way to repeat the whole reading, that you take one reading for one element of the Hall probe, then you rotate it by 180 degree to get the exact opposite voltage. But whenever you are averaging, you use the magnitude of the voltages. You don't use the plus minus, because that way you might get pretty close to zero. So that's another thing. Repeat measurement for D or R and average. Okay, yeah. So for the same coil, you do the experiment multiple times and average. I said that. Relationship is valid if the graph is a straight line passing through the origin for appropriate graph. Appropriate graph in this case is B versus 1 by R. Do not allow vague computer methods. Mane hocche, acha, cookies, do you understand what this means? I think I said what this means.
No,
Plug
sir. মানে
in
কি?
reference into a computer.
The significance of this sentence goes like this. You cannot write up an experiment that goes like this, that we attach all the equipments to a computer and the computer directly gives us the graph. You cannot say that. That's vague computer method. If you're using computer for some purpose, what type of data you're inputting into the computer, and what type of output the computer is giving you should be properly explained. For example, high-speed camera later analyzed by a computer with the time bar. That is a actual way to use the computer device for this thing. Or for example, a light gates where the inputs are fed to the computer to measure those time gaps. That's an appropriate use. But you cannot simply write that we connect all of these devices to a computer and the computer magically gives us the whole equation. That's not going to work. So that's what big computer method said. So whatever you write has to make sense, has to be done in such a way that it is achievable in a laboratory with appropriate equipment available to you.
Sir,
Follow.
method to check coils are correctly aligned in parallel. এটা কিভাবে বুঝবো? এটা কি সেট স্কয়ার দিয়ে সেট করব?
দেখো, in this part, I explained it elaborately how to make sure the coils are perpendicular onto the bench, and to measure the gap in between them, I said that we would measure their gap with a meter rule or with a predefined spacer in multiple different places so that they are exactly equal distance from each other. Yes, sir.
কিন্তু স্যার আপনি এখানে আচ্ছা এই পার্টটা আবার একটু এক্সপ্লেন করেন, আমি নিচে একটা কনফিউজ হয়ে যাচ্ছি।
এটা আপনি দেখে নিও।
আচ্ছা ঠিক আছে।
So এখানে তো just ensure করা হচ্ছে যে whether they're in the same plane or not.
Yes, so that we have the same type of, so that does not include any random variability in our experiment. Yeah.
And sir, number 4A, there's this thing called optical bench or equivalent.
Yes.
Optical bench কি আমরা কি করি like?
Optical bench or equivalent এর আইডিয়াটা হচ্ছে, আচ্ছা optical bench, আচ্ছা বলতেছি। Optical bench তো দেখছো?
তার মানে it's like যেটা beam pass করে কিছু।
It's something like this. ঠিক আছে? So what they are proposing is that we can have this thing that can go through these coils maybe in this manner, and they would be resting onto the table. Let's say, let me draw. They would be resting on the table. This optical bench will be resting on the table, and we can find out and fix up the position of the Hall probe by placing it in on top of one of those support mechanisms. So আচ্ছা আমি actually Hall probe পজিশনটা ভুল রাখছি। মনে করো হচ্ছে আমাদের অপটিক্যাল বেঞ্চটা একটু নিচে, অপটিক্যাল বেঞ্চটা হচ্ছে এই হাইটে, and then these are the legs of the optical bench. Let's say these are the legs of the optical bench based on the bench, and there comes a certain holder on which we're going to place our Hall probe to have it fixed in a fixed position. The beauty or benefit of having the Hall probe is that you can slide it back and forth, move it around to find out the exact position where your reading is maximum.
So it's like যে আমরা যে লেন্সের এক্সপেরিমেন্ট গুলো করতাম তখন যে
exactly
স্যার মাঝখানে ওই যে জিনিসটা ওইটা কি অপটিক্যাল বেঞ্চ?
মাঝখানে আমরা ওই মানে এই দুটো কয়েলের মাঝখান দিয়ে আমরা অপটিক্যাল বেঞ্চটা ঢুকাই, আমরা এই we can fix up the position of the Hall probe in its appropriate position that we want it to. This placing the optical bench is just an alternate way to make sure how you can have the Hall probe located and fixed in the position that you want it to be fixed. Optical bench is not an paramount importance for this experiment. This is just an alternative way to have it fixed over there. You can have it by stand clamp, you can have it by optical bench, you can have it by some other equipment that they have mentioned. What are the other equipments? You can have it by user set square, yeah, something like that. So some sort of variable height management system should be there so that you can find out the exact position which is at a floating point X, not a predefined physical point. বুঝে গেছে রাফি?
Yes sir.
Yes, বলো মিথিলা বলো।
স্যার আমরা তো কয়েলগুলো ক্ল্যাম্প করছি তাই না? স্যার ক্ল্যাম্পটাও তো মেটালের, তো কারেন্টটা স্প্রেড হবে না?
The wires are not connected electrically to any other components. The wire is exclusively connected through this circuit and this circuit only. The coil, the clamps of metal made up of metal they are going to affect the magnetic field definitely. That's a given. But that effect is something that we cannot do without. Whether you include the optical bench or you include a stand and the Hall probe at the center, all of these experimental setup requirements have to be there to be able to perform the experiment. So this will incorporate a, let's say, systematic error in your experiment for all of your readings, because you cannot have the Hall probe floating in space. You have to have a holding mechanism. So whatever it is, this will essentially do some uh, bring about some variability in the orientation of your magnetic field strength, but that is something that you cannot do without. So that's an experimental hazard that you have to will to sacrifice in terms of the quality of the experiment, because you have to hold the Hall probe in there in by some case. One of the things that you can do is that other than placing metal stands, you can use plastic stands, because plastic stands are also available these days. That can essentially have you a bit less effect on the magnetic field maybe, other than concentrating it at around that location. But whatever you use, you have to use the same setup, setup mechanism throughout the experiment. That's very important. Bucho,
Yes, sir.
beautiful. Let's go for the similar question that I just found out. Can anybody remember what? I think it was October number 18, was it? Similar একটা question দেখছিলাম না একটু আগে? Someone?
So 17 ছিল মনে হয়।
হ্যাঁ স্যার 17 5-2
এটা খুব ভালো একটা কোশ্চেন বাই দ্য ওয়ে। নেক্সট ক্লাসে মনে করো এটা ডিসকাস করব। জোস একটা কোশ্চেন। Weird but জোস। This one? Yes. We have some time, so let's give it a try for voltage. In this case, we are actually dealing with voltage, which is beautiful. A flat circular coil P carrying a current produces a magnetic field with the second coil Q placed at its center, with its center at distance x from the center of coil P as shown in figure 1.1. And EMF V may be induced in coil Q. So there is coil P, there is coil Q in distance x. You have to somehow be able to measure the distance. So strings can be of very beautiful use. You can have crossed string and measure the distance between the crossing of the strings. It is suggested that the V is related by the it is suggested that V is related to X by the relationship V equals to V naught e to the power minus kx. Okay, what is happening here? A flat circular coil P carrying a current produces a magnetic field. Okay, this is producing a magnetic field. When a second coil Q is placed with the center distance x from the center of coil P, and even V will be inducing a coil. Okay, we're inducing a voltage V in the secondary coil from the primary coil, which essentially means the primary coil has to be run by an AC. That goes without saying. You cannot induce any current over here by using a DC. So this coil has to be supplied with an AC supply. First thing first. It is suggested that the V is related to X by the relationship this much. So how much voltage would be produced in this coil is given by this relationship, where V naught and K are constants. Okay.
আর এখানে কি লন নিতে হবে না আমাদের দুই সাইডে করে y = mx + c যদি আনতে হয় ওই ফর্মে?
Yes. Design a laboratory experiment to test the relationship between V and X. Explain how this could be used to determine the value of K. You should draw a diagram on page 2 to show in the end of the equipment in accordance to particular relation to blah 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 blah. Okay. So all the other stuff that we discussed in the earlier experiment also goes over here. The essential part which we have to make sure not to change is that in this case, okay, let me go through. We're gonna have two coils which are not gonna be changed. So we make two coils and they can be used for all of our reading. Here the independent variable is the X, which is the distance between the two coils, center of the two coils, and the dependent variable is the voltage that is created on coil Q. The control variables would be, in my opinion, the current flown in the coil P, number of turns in coil P and coil Q. This has to be kept constant. Did they ever anywhere say that these two coils are identical? Flat circular coil P carrying a current produces magnetic field. When second coil Q is placed with center, now they didn't say anything over here. These two coils are identical. So we have to say that these two coils Same coil should be used throughout the experiment. And what other control variable can you think about? Coils should be placed parallel to each other. Their centers should align. Yeah, this is stuff that I can think about. Okay, and also, how would you draw the figure or electrical circuit for this coil? Let me here, and I can try to draw some stuff.
স্যার এটা এসি কেন হতে হবে কারেন্টটা?
How would you induce a voltage on the secondary coil from the primary coil if the primary coil is not running AC? If you run a DC in the primary coil, would you be able to induce a voltage in the secondary coil? Think.
স্যার কয়েল কাটিং এর জন্য এসি লাগবেই আসলে, মানে
হ্যাঁ।
কন্টিনিউয়াস কয়েল কাটিং এর জন্য আর কি।
মিথিলা, বুঝছো কি বলছি? We are
হ্যাঁ মানে
inducing voltage in the secondary coil. So other than yeah, you cannot do this. So let me get rid of this thing. So I'm trying to draw multiple stuff that I can think about, but anything that pops in your head, you can also add. First thing is that we have to run this at a fixed voltage and current for all the readings. So we should, to make sure that it is done at a fixed voltage and current, we should have voltmeter and ammeter as well. And might as well throw in a variable resistor over there for the sake of controlling if this is needed. So this coil should be run with AC supply, with a switch, with an ammeter, with a variable resistor, just for the sake of controlling the behavior. And it goes on over here. And to observe its voltage, we can also connect a voltmeter across the coil, not across the source, across the coil. So on the two sides of the coil. So this is the workable circuit for the primary coil, which these two things should be constant throughout all the readings. And then to measure the voltage of this coil, we can simply connect voltmeter over here. Nothing else would be required. X can be measured by a meter rule. Voltage can be measured by a voltmeter, and the rest of the details are, I think, pretty simple. The only thing that remains in this question to discuss, I believe, is as for the precaution is pretty simple, that we should work with a big enough voltage and ammeter, and we shouldn't have the distance X too large, so that the voltage induced in the secondary coil is too small. I mean, the voltage induced in the secondary coil should be pretty significantly large for it to be measured by the voltmeter. So having a big number of turns of coil is a pretty good recommendation, so that you can have a much bigger voltage induced over here. So both the coils should have a significantly higher number of turns to have significant EMF induced in coil Q. That's an important recommendation you can make. However, the coils should not be run for too long at a time, so that they will heat up too much. We should not touch them while the coil is running with bare hands. There is possibility of burning and blah blah blah. Everything that I've seen in the earlier experiment. I'd show you the manipulation of the equation a little bit, which is V equals to V naught e to the power minus kx. V equals to V naught e to the power minus kx. So we are trying to find out a relationship between V and X. So X is our independent variable, V is our dependent variable. So let's take ln on both sides. So ln V equals to ln V naught plus ln e to the power minus kx, which if we do ln V equals to ln E means k simply comes in the front, and ln E equals to 1. So it becomes minus kx plus ln V naught. So that's basically your final equation. So what we're going to write, that ultimately after having all the set of values, we're going to plot a graph of ln V versus x, where this is your y-axis variable, this is your x-axis variable, and this should give us a straight line that does not pass through the origin. If it does not pass through the origin, then the relationship is valid. The y-axis intercept gives us the ln V naught, and the gradient gives us k. So you have to write them in words.
Sorry, এখানে তো আমাদের এই যে ভোল্টেজটা it will keep on varying because of the DC. Sorry, AC. তাহলে আমরা কি বলবো যে we should calculate the RMS voltage by এরকম কিছু?
Well, whenever you calculate, whenever you connect whenever you connect a voltmeter with an AC supply, the voltmeter typically always gives you the RMS value. Typical voltmeter. For example, the voltmeters the multimeters that you have used in your laboratory. In that part, there was a certain segment of the radial display where it showed the AC voltage. So, though typical multimeters that we have access to in laboratories, they always measure the RMS voltage of an AC supply, irrespective. If you want to measure the maximum voltage, then you need to multiply that by root 2. So whatever you measure over here and whatever you measure over here, I mean, if you don't change the setup of your multimeter throughout your experiment will work out just fine. For example, if you measure the RMS over here, whereas if you measure the maximum over here, and if you measure this exact same things, well, if you measure the exact same things over the duration of your experiment, then your experiment will work out just fine. You cannot simply change RMS to maximum or maximum to RMS in random places. That's very important. When you keep your apparatus settings in the same setting for the experiment, that's what matters. Ultimately, it would not matter. Buchik will see.
Yes, sir.
Let's have a look at the mark schemes to find out what they have to offer us. This is question number, this is October 1752. When 1752 will be located in page number 311. Almost. May June 7. এটা কত দেখছিলাম? ON 1752. What? আচ্ছা আমি A17 দেখে ফেলছি, সরি। W17 যেতে হবে, my bad. W1751, W1752. X is the independent variable, V is the dependent variable, or vary X and measure V, keep current in the coil P constant. Okay, they only mention current. Method of data collection, label diagram showing both coils supported. Okay, obviously, stand clamps are required. Two current circuit diagrams for coil P and coil Q, power supply connected to one coil and voltmeter, CRO connected to the and voltmeter or CRO connected to the other coil. Okay, any of them work. You can use a CRO. Method to determine X, example, use a ruler drawn, label horizontal ruler adjacent to coils with X indicated. আচ্ছা, to be able to, আচ্ছা এখানে আরেকটা জিনিস হচ্ছে in this, for this experiment, this is very important for me to discuss. For this experiment, we have to measure the ambient distance between the two centers. It is not important that we have to measure the distance exactly at the center. We can very well measure the distance at the bottom, as long as we can make sure that they have the equal distance all over. So to make sure that we can measure, we should incorporate in our discussion that we measure the distance of the two coils in multiple different places to make sure they're parallel to each other. And you can pretty well measure the distance between the two coils exactly at their base, because whatever you will have at their base would be pretty much same at the center to center. But it's what goes without saying. If you're measuring at the base, what I'm trying to show you over here, you should either measure. Now you should definitely measure from similar surfaces. For example, the X is supposed to be from center to center. So you can either measure from here through here to get the center to center distance, or you can also measure from here through here. So either from left side to left side or from right side to right side, because the average would essentially end up being the exact X. But you should not measure from right side of this coil to the left side of this coil. That way you would get a value less than X. Do you understand what I'm saying? Follow on. বুঝছো কি বলছে?
জি স্যার।
Similar side গুলো যদি measure করি, automatically আমরা X এর ভ্যালুটা ওই by default ওখান থেকে পাই যাবো. So that shouldn't be a much too difficult thing to do. And then if they say method to measure X from the coil center of the coils, or measure width of each coil and divide by 2 and add to the separation of the coils. Or if you mention that they are coil made with on the same side, or you can go for exactly what I said, that measure from side to side. That also works. This is just an example. but what I said can also work. Plot a graph of laundry hue against X. Relationship is valid if straight line is produced, K equals to minus gradient. Additionally, do not touch hot coil, use gloves to position hot coil, heat proof gloves to position the coil. Use large current to number of turns or iron core to produce large magnetic field. Okay. They have also proposed a incorporation of an iron core to have a much stronger induction in the secondary coil. Works, but I think these two are much easily achievable, larger current or bigger number of turns. Use a high frequency to produce a large induced current. Okay, the source should have a higher frequency. I did not say that. Yeah. So this is also to produce a high induced EMF. Same purpose. Use an AC power supply for or signal generator connected to coil P. So you have to have an AC supply onto this thing. As for this whole diagram, they have not mentioned that the coil P has to be supplied with AC. But this experiment at all will not work if it is supplied, if coil P is supplied with DC. But what they show us over here, that using an AC power supply was given as an added details, not a primary requirement. I don't know how that works, but well, they think it that way. So showing an AC power supply scores the one additional mark. Keep the number of the turns on each coil constant or frequency of if it is constant. Method described to check that the current is constant with an ammeter and variable resistor power supply. I included that. Repeat measurements for X for different parts of the coil and average. Repeat measurements of X for different parts of the coil. What does that mean? Repeat measurements of X. Oh, acha. Parts. Do you guys have any idea what this means? Different parts of the coil? Repeat measurements of X. So we're gonna different parts of the what? I don't have any clue what this means. Are they proposing something like maybe that we should have this coil in one orientation and then measure the voltage at one point, then we rotate this coil by let's say 180 degree or 90 degree and take 2 or 4 readings? I mean, different parts of the coil, how does that work? Although a lot of people have left, but for those who are here, I'm not sure what this means. I honestly am not sure what this means.
Sir, are they referring to different orientations? Like একবার হচ্ছে সাইড সারফেস থেকে আমরা এক্সট্রা মেজার করব, তারপর টপ থেকে।
Oh, acha. So X should be measured in different places. For example, let's say we measure the X over here once, and then we measure from this surface to this surface, and then measure from this surface to this surface, and then on the back to back. And we use all of those individual X's and then average to get a round of value of X. That's what I'm saying. Yeah, that can work. That can work. So this was a way to measure different values of
Are they talking about X or V?
X, only X. Repeat measurements of X for different parts of the coil and average. Yes, to get a more reliable value of the X, not only measuring it exactly at the center, we can measure it in multiple different places and average. Yeah, that can actually work. What I said is that we make sure that the coils are equally spaced in all the places and only measure the X at the bottom. But what they're saying that other than doing that, measure it in different places and use all of those data to find the average X. Yeah, that also works. Makes sense. Now it makes sense. Yeah, Rafi, thank you. বুঝছো কি বলছি বলবান? Measure the X different places and having it average actually does a better job. Method to position rule horizontally to measure the X described using a spirit level of same height from bench at both ends. Okay, so they are proposing a way to measure the X exactly at the empty space or in between floating points, but I did not propose that. I propose that we measure the distance exactly at the on the table. So you show the table and you measure the distance at the table level. So you would not require a speed level for this one. But if you want to actually place, if you really want to place a meter rule exactly through the middle, then you would have to have some support mechanisms over here, and you can place the meter rule over here, and you should place a speed level on top of the meter rule to make sure that that meter rule is horizontal as well. Why bring these steps? I mean, this is unnecessary, but okay, if someone thinks in that manner, why not? They should get this additional mark as well, be my guest. Method to keep coils parallel or coaxial. Example, adjust coil Q until maximum reading or set square to ensure that the coils are at right angles to this axis. This is a default data that we discussed for the earlier question, which I not here anymore because I deleted this part. So এর আগে যেটা ছিল যে we have to make sure that the coils are perpendicular to each other, parallel to each other, and also perpendicular to the bench with the help of meter rule and set square. You can essentially go ahead and describe that. And then the conversion of the equation. Ultimately seeing the equation in this format: long d equals to minus kx plus long d naught, minus kx on the front, long d naught on the last, so that you can actually have a graph like that. This actually gives you this thing. এখানে একটা ইম্পর্টেন্ট জিনিস আছে, relationship is valid if a straight line is produced. They only mention this much, but I highly recommend that you write a bit more. What I would recommend that you write relationship is valid if a straight line with negative gradient that does not pass through the origin is produced. Write the whole thing because it's not very difficult for you to write that. You can see that this is a negative gradient line, so this should be a straight line with negative gradient, and it should not pass through the origin. That should prove that the relationship is valid. বুঝে কি বলছে?
জি স্যার। স্যার ক্লাস কি শেষ?
Yeah, I wouldn't pick up a new question today, but I'll pick up class. Please, thank you very much. আর হচ্ছে আগের ক্লাসের লেকচারগুলো আমি যে তোমাদের ক্লাস শুরু করার একটু আগে আপলোড করে দিছি. They should be available right now. Names as well, so you can look up those as well. Thank you very much. Good night.